Hello guys, welcome back to the channel. Today we'll discuss the chemistry and chemistry which is very practical to use, right? Oftentimes we heard about that, chemistry is about mugging and not solving about everyday life's problem. But today I'll break this notion by solving one of the problem and show you how you can use chemistry's principles in everyday life of solving the problem. Let's take an example of one experiment. So let's say we have one candle, okay? Candle, um, and it is weighted weighing machine. It is weighted as initial weight as let's say T at 0 is we found something, let's say 5.5. And then what we have done, we've taken one tumbler glass, right? We put it upside down, okay, and let's candle burn after t time, okay. This is t0 position. After t time it got burnt off, right? And then we measure its weight. Let's say here it was 5.5 gram. After burning we found its weight as um, 5.55 grams. Sorry to use weight, it's mass actually. So, so how much um, paravaccine or wax has burned? So wax burnt is 5.5 minus 5.4, so point 1 gram, or let's say it's 49, so 0.01 gram. Okay. Now what we will find is that here is oxygen, and to burn the wax we need oxygen, right? And if it has burnt off automatically, that means the oxygen it required has depleted. So we need to find out how much oxygen it took to burn its this mass burn. Okay. Now in this experiment will the physical chemistry, the organic chemistry, all will be used. So okay, so for example, let's take the scenario. So what was the scenario? The temperature was 25 degree or 27 degree room temperature, okay. And to convert it into Kelvin we need to add 273. So let's add 27 and make it 300 Kelvin. Pressure was 1 atmospheric pressure, which is 1 Pascal and would come at Newton per meter square. Everything to be put in SI unit. Volume of the glass was like half liter. Half liter would be 0.005 cubic meter. I think 10. So maybe 5 into 5 into 10 to the power minus 3 meter cube, right? What we can take more, so since we'll use the PV barabar nRT to find out how much mole of the gas was present in the tumbler, the glass, okay. So we need R in SI unit happens to be I think 8.21 or 8.3. Let's take 8.3 with the SI unit is joule per Kelvin per mole, right? So by putting it here, we'll try to find out the mole of air present in the tumbler. So R we put it 8.3, it will take 300. So what will happen? It will come as 10 to the power 2, and this will cancel out, and mole of the air present in the tumbler would be how much? 5 upon 8.3 into 3, right? And this will, I think, oh, this is 10 to the power minus 4. Sorry, my bad. So it will become 10 to the power 3. Again, this will cancel out and it will become 83. This will come around 0.02, right? So 0.20 mole of air in the glass or tumbler. Okay, so this much air was there. So how much it got burned, right? So let's use a different color. So, and in 1 mole of air, right, 1 mole of air, what, it's a mix of O2 plus N2 plus other gases, but we'll take 75% is this and 25% is this. So let's take 7, this is 21%, so let's take it 20%, this would become 80%. And 1 mole O2 is how much? 32 grams, right? And 1 mole N2 is 28 gram. So 1 mole of air would be, since N2 is 80%, 80% is 4 by 5 and 1 by 5th part is would be 32 gram of oxygen. It will come nearly 30 gram, near to, because it will be more near to 28 because it is 80% available. So the mixed quantity near to 28, farther from 32. So 30 would be, I think 29 would be the number, but let's take 30 gram for ease of the calculation. I'll use the blue color only, I think it's, or maybe black. Okay, so now 1 mole of air has 30 gram of N2 plus O2. The mass of 1 mole of air would be 30 gram, right? And 1 mole of oxygen would be, out of this 30 gram, would be 20% of 30 would come around 6 gram. Okay, now how much of mole of air was there? 0.02 mole, right? So out of 0.02 mole of air, how much would be oxygen? 6 gram per mole, so 0.02 into 6 would come 0.12 gram of oxygen out of this much mole of air. Okay, now we have to find out how much oxygen was burned to burn that paraffin or wax, let's say wax. So what is the wax formula? Wax is a petroleum, and it is alkane of 31 order. Alkane is nothing but like this type of hydrocarbon. So it's like C2 and H6, so CN H2N plus 2 type, right? Okay, and the wax is of C31 order of carbon of alkane. So C31, H would be 31, 32, 31, 262 plus 264. So this hydrocarbon, if burnt in the presence of O2, will make CO2 plus H2, the basic alkane properties in oxygenation. Now we have to balance this. So 31, so balance the metal part. So 31, and then oxygen we have, so 32. Now oxygen how much? 31 31 and here 16. So 31 plus 16 would be 47. Right. Now the weight of this would be 31 into 12 plus 64 into 1, which will come around 436. Okay, and this would be 47 into 32 will come around okay, so 50 into 30 would be 1500. Okay, minus 3 into 32, roughly around 50. So we'll multiply like this: 15 into 30, right? Or let's take 32 minus 3 into 32. This will come around 6, 9. This will come around 16, which will come around 1504. Okay. Okay. So 436 gram of wax or moam requires 1504 gram of oxygen to react. Now 1 gram of wax will require 1504 divided by 436, and there was how much wax burnt? 0.01, right? Yeah, yes, this much. Now this will come around, so this will 436. We'll do some rough calculation. 3, an order of 3, right? So it will come around 0.03. So 0.03 gram of oxygen needed to burn 0.01 gram of wax mombatti. Now how much we've calculated the oxygen was in the tumbler was this much, 0.120 gram. 12 gram. And how much burned? How much burned for the reaction? 0.03 gram for 0.01 wax. Now how much oxygen was left? Was around 9. So that means most of the oxygen in the tumbler haven't been burned, because 9 of 12 is around 3 or 4, which is nothing but 75%. So 75% oxygen was not burned, only 25% oxygen was burned. Why? Because if we put it like this, and mombatti was kind of this, so the oxygen which are of this order, like which are 25% of height, will be burned, because once it is burned, it will convert into what? CO2, and CO2 being the warmer air will come on the top, and the oxygen, remaining oxygen, would be dumped down on the basin. So 75% oxygen will not only reach to the flare of wax. So that's why. So now this calculation proves the exact experiment. Thank you everyone.